So second part for component architecture, and I just want to recap the first two chapters, which is haptics and patterns. So haptics is where we have the interaction with the component from an outside level. What are the mechanics we can use? And then patterns is looking inside of the component, how they are working under the hood. So now next up is types, classification, styling, and then lastly putting this into practice, some hands-on guides. All right, so next up is then component types, and types are more around their purpose. So as for each chapter, Bob and Greta are here to help me out getting this across. So Bob and Greta are like the two cars, and like the purpose is what we want to do with these cars, what we want to use the cars for. So where are we heading with them? And for Greta, like this is like the bully is super suited to actually go on a road trip. Like if you're in Europe, going north, like Denmark, Sweden, Norway is a nice journey, nice route. Or if you're more like in near of coastal area, then you want to make a trip to the beach. Whereas with a Mini Bob, that gives you definitely some go-kart feeling when you drive it. So more some a little racing going on. So definitely two different purposes that we want to use the cars for, as you cannot put a surfboard into the Mini, or it looks very interesting. So what are we using types for? And I defined them as a common and repetitive use case, which results in a given set of haptics and the possible patterns it implements. So types are by far the most written things when it comes to component architecture in terms of what I could find on the web. So there's lots of articles, lots of blog posts, not only in Ember, but also many are coming from React. And you can apply and transform the knowledge to basically any framework. So this is why for each type I find or was able to find, I put the respective material just on the introduction slides. So presentation and component is the first type I'm going to present. And I tried to put them in such a type component spec, and let me orientate. So in the top left, we have the synopsis, and then the principles below that. And on the right, there's some space for additional information depending on the type I'm presenting. So for the synopsis, this goes back to the haptics that I've outlined before. And a little addition to that is also the logic that may come with such a component type. So the intelligence level can be like smart or dumb. All right, so for the synopsis for the presentation component is we can have both types of invocation. They come styled, they come with content inside, usually not that much for structure that they provide, and they are by far the dumbest type of component. So for the principles is that they are concerned with how the things are looking. They are pretty much isolated, have no dependencies to the rest. They are also not responsible for any data loading or mutation of any existing data. They receive data and maybe some callbacks like via arguments. They usually do not have any state except maybe their own UI state, and they are rendering as minimal elements as possible. So as an example here, I do have an avatar component. On the top is the template. It's just an image tag, and it renders the source that we pass into. We apply a class to it and optionally take additional attributes. And then the class below, the CSS, is just basically saying, okay, we are gonna make this in a circle shape with a width of 50 pixels and a little border around for a good contrast. And we use box shadow for that actually. So how this looks in practice is here I'm using this avatar component. I pass in a source here. This is my GitHub avatar, and then just some alt attribute. And so yeah, just as said before, very like plain dump. I just pass in data, and then it renders it the way we want it to be. Next up are container components. Now, at this time, I think it gets a bit of interesting because the literature I found is a bit fragmented, and the container components, they are very much unclear about what they are referring to. So this is why for container components, I made the synopsis for everything unclear or like as a question mark, because if we look into the literature, some describe it as a logical thing only. Other describe it as a thing to structure other things on the page, like more in terms of a layouting component, or you can say they are any arbitrary form of grouping components within them. And that is or can be very application or system specific. And also there are some dichotomies that come with it. So some are stateful, others are stateless, some come as classes, and others come as functions. Like you can clearly see, this is something coming from React, where they move from classes to functions. And it also can be pure or impure. So there's also like some of them are, or like an also known as is what I put on the side. So if I figure out there's more names to it, then I put them here. So there's also a wrapper component that these components are referred to. So instead, we can look into concrete container components, which are provider components, composable components, and data entry components. So let's start with provider components here. And provider components, they come come in terms of a block invocation mostly. Usually they have no style, no content, and no structure, but they are smart. They bring some logic with them. So for the principles, they are pretty much concerned with how the things are working. They contain the logic. Most of the time they're renderless, maybe sometimes some sort of repetitive or so. And ideally, they just yield data and functions for further interaction with the business logic you're handling here. So an example here is a data manager component. So on the top, again, is the template. Basically, you see there's no elements. It's just yielding back some information, some data points. We're yielding back some items and some sorted items. And the component, like the backing up component class here, you can see we can take items as an input, and then the sorted items are only made up within the component, like computed on the fly. It's handling only an array of data, so nothing very fancy, just pure array handling in this case. But like you can grow that a bit bigger to like add filtering or add pagination, for example. So how is this component working? So we invoke the data manager here. We pass in an array of items, banana, apple, and ananas. Ananas is the German term for pineapple. So I just got confused when I wrote this. And then we yield back the information as data. And here we iterating then over the sorted items. And so this is why we have ananas, apple, and banana in the sorted order rather than the order that we put them in. So here it's just array handling or some data handling, but of course this can be anything related to your business logic. Composable components. I think now it really gets interesting. And maybe some of you have seen the talk or the talks from Miguel Camba at EmberCamp and EmberConf. I think one of the most iconic talks in Ember. I think for the Emberfest one, it was using some RPG-based style, and I think Super Yoda also was the star of it, something like that. Very much remarkable, really good talk, really good if you want to see something else in the Emberland around this. So for composable components, they most of the time come like both invocation styles. They can be style, they can have content, and they can have structure. And for most of the time, they have some logic. You might also know them as high order components or contextual components, as these are the names that they go by in the literature. So for the principles, it's mostly that they are concerned with how the things are connected within their own components or within themselves. That also means they may contain some presentation components or also other container components. They may act as a wrapper, but they also function themselves. Or they may yield components, so you can compose them the way you want, but the component itself makes sure that those components are wired up in the way it needs them to be. So for the patterns that it may implement is that they may use the strategy pattern, the builder pattern, or the facade pattern. So, and then I looked a bit more into it and found some usages as we've seen them in Ember apps already today. So the first one is that they act as a composite where it connects internal components together. Second is that they act as a kit. So block only, and then they yield some construction kit for you to compose the contents as you wish. And then the third thing is some sort of like a chameleon, where in the inline invocation, they do something internally, which is somewhat as sensible default that we can refer to. Or if we go into block level invocation, then it becomes our customizer kit in which we do the things as we plan to lay them out. So for the example, here's a toggle component. The template is, and the template I'm showing here is quite big as it's the live code to add the demo I will show you afterwards. But I want to highlight or like focus 3 blocks in this template to you. So the first one is the has block params. So if we use the block params syntax before, like blah, 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 as, and then inside of the pipe characters, we ask for some parameters. In this case, we want to yield out a hash of the components, like in this case, a label and a switch, and say, okay, here's your components, build the component the way you want it. No longer our business. Second block is if we have a block given, but not asked for parameters. In this case, we build the component as we are doing. And importantly is in this line, we use the yielding as saying, okay, we take for the like default block, we take your input. And then in the else case, the last block is the sensible default in which the component is rendering it as the author has designed it in for the default use case. So let's go over these use cases and how you can use them. The first one is like inline invocation. We use the sensible default as given into. So the slides make the text a bit bigger than actually the checkbox inside. So don't be confused by that. But the toggle label in the middle is turning the box on and off. On the off label, I will always turn off the value. So even if I click it multiple times, and on the on label, I can turn that only on. So I can use on, off, but no like off twice and on twice doesn't do anything, but the toggle of course does. So I pass in the label for the middle, the on label and the off label. So now we can use the block to design or change the design of the toggle label. So here we go into block invocation, and inside the block is what's becoming the label. So we have an additional chance to, or we have a chance to use additional HTML and can go as fancy as we want. In this case, I just made it strong or bold. Like when we go into kit mode, where we say, hey, please give us the component. We store it in the T variable, and then we can use the label, the switches, or the switch, and then the labels, and can build it the way we want it. We say here's the value. This is how we turn, like how we want the value to be changed whenever we invoke this label. So on the left, the on label is always return the label on, and on the right is off label, bit switch to what it was before. And we also gave it some colors. So a bit like I think the Mexican flag or also the Italian flag, if you rotate your head a little, just because of using different colors here. And the last invocation is kind of using the strategy pattern here. So we pass in a label component from the outside. In this case, we just have a fancy label, and then the component itself is rendering our label that we're passing in. And the fancy label is basically a decorator component. It's just using the label from the toggle component itself and apply some styling on it to make it pinky. Next up is the data entry component. The data entry component or type is actually consisting of multiple components. On the first level, we have a collector component. It's invoked in block invocation. It may be styled, it may have content, or like it will have content, and will have structure, and it will have logic. And then a second to it, or like the tandem kinda, is the entry component, most likely inline, but also sometimes can go into block level. It's not styled, it doesn't have content, it doesn't have structure, and it's also very dumb. So the way it works for the principle is that the collector acquires the data through the yielded entry components. And then you can use the entry components to enter declarative or to enter data in a declarative way. And then the collector can decide whether to display the data directly or to yield the data. So inside of that, we can actually do something else. So this is actually a bit inversing the data down, actually it's up to data up instead of down. So here's an example. Here we have the leaflet map, which is from the Ember add-on Ember leaflet. So we construct the component here. That's our collector. We pass in the required arguments, lat, lang, and zoom level. And then we get back the layers of like as black params, and with the information that the authors of this component yielded out to us. So the leaflet map is the collector, and now we are entering data through their yielded components. So at first is that we give it a tile as we need it, and then later on we can put markers on the map by using the layers marker here. So let's look at this, how this looks. Here I need to refresh the page because Reveal.js thinks of changing things for the demo, but here is basically the map. I can pan around, I can zoom. So here we are in Frankfurt, and this is the Clark headquarters. So for what you want to use those components for, these types of components, is whenever you want to enter data in a declarative way. So map is one example. Another one could be that you have some visualization charts or some other visualization tools. So on the collector, you have the chart or the visualization library itself. and then you yield out the entry components. So whenever or wherever you get your data from, you can each over that data to, for example, put markers on a map, or to put lines in a bar chart or in a line chart. So to have some data getting through the template into these components, and basically make use of the reactivity level here. So whenever you change the data, then the data point will be shown or not. So discussion for the whole component types. The haptics are basically our first indicator for a type. That's why I like always put them here as well. It's not a promise, it's not a guarantee, but a good first indicator. Types are quite solid, but also ambiguous at the same time. Like, the literature is a bit fragmented. Names are used to describe different types. So you always need to keep an eye, or whenever you're discussing this with somebody else, to make sure you're talking about the same thing. And one thing I really like are those chameleon composable components, as they are very powerful when they provide themselves a sensible default, but also allow you to go into this kit construction mode, and then you can build them the way you like. Again, here as well, use the right tool and don't abuse them. So don't make a component into one of that types because you want to try out that type, or think that's now time to try that. Make this a good judgment whether you need to use them or not, and whether it fits your purpose. All right, so for adding them to our component specification template, you see I've already made the types in there, and we can add them. And so this allows us to describe a component further with those types. Next up is component classification, or the home of a component, where it lives. So again, let's think about Bob and Greta. And the big question here is, where do they park? So you return from the racing track with Bob, and you return home. And where you're going to park your car? In front of the house, on the street. Maybe you have a carport. Maybe you have a garage. And for Bob, as one of the like smaller cars, there shouldn't be much problem to find enough space to park Bob. However, for Greta, it's a bit more difficult. So when you want to park Greta in your garage, is the garage high enough so Greta can fit through a door, or does the height of the door stop Greta from coming in? Or same question when you want to park Greta in the carport. Does it actually fit in, or like, is the dimensions of the car too big for the space you have available? So things like that. For the definition of our components is that the classification gives a home to a component and can be accompanied by naming conventions and or guides or guidelines. So when it comes to components and we think about where they belong, the first thing that comes to my mind is perhaps Atomic Design by Brad Frost. So he already gives us an orientation from atomic components over molecules, organisms, templates, and pages. And I think that's what many of you perhaps are already familiar. It's like going from small to big. And it's like we take that as a good first orientation, and this is our first axis. Now we need to find another one. And luckily, Brad Frost also gave us the second one. So he speaks about the layered system. On the lower level is the design system components. Then in the middle layer are recipes. And then on the top are snowflakes, components like for one situation, one-offs, only use them one time. So, and I don't know if this was the intention, but I made this one. I put them on the two axes and form the grid. And now I can say, okay, let's mark this grid of where we want to have several components to be their home. So let's put some checks mark in and say, okay, for the pages, they should be snowflakes, templates and organism, there should be recipes somewhere in the middle. And then the design system components for this case are living on the lowest layer and also are one of the smallest components in our whole application or system. So that's a good orientation. How do we go from that? And what can we do with that? So first of all, I think it's great to create a map of your own system that also needs to fit your architecture. And then when you have that map, draw some zones to make boundaries and name those areas. And this will make actually, as a first step, will make those boundaries visible. And then as a third step is to set rules and guidelines for each of those areas. And then these areas define what kind of components can go in there. So I made this myself with Hokulea, which is my research design system. And I made a map like this. So it looked like this. So here on the top level, this is the same axis coming from Brad Frost as well. So atoms here, then molecules, and then for templates and pages at A. No, this is product level, not necessary for me, but subatoms or ions is something I could make use of. And then on this axis, it's like not an axis where you can increase the size. It's just an enum kind of axis. Some internal things, building blocks, and then the user-facing components that one might use. So now the interesting thing is actually the column in the middle. I found some construction components, usually some things that are builder components or some base components to provide generic or cross-cutting structure. And then interesting is the primitive components here, container components over here, and composite components down here. So that was just not yet fully enough for me. So I had some problems like making the boundaries visible for them. So I looked a bit further down. So here is where I looked a bit more in depth into these user-facing components. Containers on the left, primitives on the right, and then I put just some squares around them to group them. But and like I like colors, so I put some colors on it, and that made it a bit more visible to me of what these components are, how they can be structured and organized and stuff like that. So that's still work in progress. What it helped me on the first glance to actually derive some guidelines and some rules for these components. So here they are. These are for primitives, so just one sentence or like a paragraph to describe what primitives are, and then a list of guidelines, of rules of what they can do or what they should do, what they should not do. And then I have some examples on the bottom where just some components that are marked as primitive. So any button, any input component, any sort of badges, icons, or menu items. So next one are then container components. Also like a little explainer up front, and then rules and guidelines, what they should do, what they should not do, and then some examples here, in this case, modal and cards. And I continued doing this for most of these classes I found. So discussion for this classification chapter. Classification is kind of a map for your components. It's very much fun to do that. The containing areas for your components, like a map contains these areas for components, and it makes these boundaries visible, which is like super hard to actually anyway communicate this to your peers if these boundaries are like very shallow and are not really much understood across the team. And then each of those areas, each of these classifications shall provide some rules and guides for each area. So if we add the classification to the component spec template, it just says build your own map, because there's no recipe that you can use. You need to fit that in your own application, in your own architecture. All right. So next up is styling. As for each section, Bob and Greta are here to help me. So styling, first thing that comes to mind is how we color things, but also how we actually maybe arrange things and lay them out. So for the colors, I mean, the Greta, the bus here is orange. That's good because it's already matching my beard color. And I think every car should be orange, some sort of, but I also like the green of Bob. Or what if you are buying a car and you're actually going through the customizers, then you want to choose the color that fits your style, is your favorite. So you want to repaint the cars. So not only you want to repaint the cars, but also what you can see from the outside is perhaps the wheels, the rims, and how you want to change them. Maybe you'll like some others. But more interestingly is not only what we can see from the outside, but also what's inside the cars. So in order to do that, we need to lift the roof of them. So we can look inside. And now we are seeing, for example, the seats and the seat color and the seat material. We can also look at the steering wheel. So we want to change like the material here. We want to change the color of the seat materials. Or for the bully, we maybe want to change something of the interior. Or also we want to change the sound system, if it's called like this back in the days, of whether you want to have a cassette or not, or just radio. All right. So with that, let's go into a definition. We want to formalize CSS API that exposes various parameters to us so we can customize the appearance. And so we need to look into state of CSS for that to see what kind of things we have available to us. So state of CSS, the past, but maybe still today, is we're using responsive web design, which the term was coined by Ethan McCott in the year 2010. So 12 years ago already. And it kind of like focuses on breakpoints to use them to adopt to small screens, or like we use them and we also abuse them. So I always think of them as when I go and want to buy a t-shirt for myself and then I'm asked how tall I am, I think, thank you. I only need a t-shirt for my torso, but not for my whole body. That's enough for me. Then this is sometimes what we see for breakpoints and how they are used as well. So we check for the width of the viewport, but we only want to rearrange the layout of a component or an area of the document that is not contained within the full document or within the full document width. Also, it has become somewhat popular through Bootstrap, as they were kind of like the first framework or library in which they made the use of breakpoints popular. And then some best practices and methodologies have evolved, some to avoid the cascade rather than to putting them at use. And also, when you are in such a situation, then maybe I've used important, like the symbol of resignation when you give up fighting against CSS and say, no, please take it. There's so many things where the cascade actually is not working for me, but against me. And also is that we actually write more CSS than we need to. So yeah, and when we put this into frameworks, then we solve a lot of styling through HTML and JavaScript rather than using CSS to solve the styling. So the state of CSS today and in the future. So what's changing? At first, there is this Compat 2021 mission or project by the major browser vendors from last year, and they fixed issues or misalignments in different CSS technologies around Flexbox, Grid, Position Sticky, Aspect Ratio, and Transform. And over the course of the last year, they improved heavily in these. And by the end of last year, there was a report that showed that they are now at somewhat 90% feature alignment across all major browsers against the specification. So that's quite good. So they made the platform more stable and resilient for us to use. The next, because that was actually a good thing, they continued for this year and call out the Interop 2022, in which they focus on layers, containment, some color-related functions, subgrid, dialog, and actually a couple more things. So these things are coming, and it's looking very rosy future for CSS, which allows us to do biophilic web design, as I would refer to it, and Google calls it the new responsive. I use biophilic web design because that's coming over from architecture. In biophilic architecture, they use nature to their advantage. So they use plants and water to actually for cooling systems of houses that they build. So, and when we transport this back into web design is to use the platform, the web platform, to our advantage rather than let it work against us. So what that means, first, embracing the platform as it is, which comes to responsive to user preferences, like color scheme, contrast, the animations that we may want to show, whether they are like reduced or not, and then also to different viewports like small form factor devices like mobile phones, watches, then up to the bigger ones like tablets, desktops, and TVs. And also form factor, which means like the foldable devices that are coming. So we have this kind of sort of split screen. I think that's still for all of us to explore. And furthermore, when we think about layouting, that we can use intrinsic layouting, macro layouting, or also on the other hand, primitive layouts or layout primitives. And then actually to solve styling in CSS rather than in HTML and JavaScript. So this is coming with CSS. So one more thing we need to look into is the global versus scoped CSS thing. So all CSS is global by default. The only real scoping we have for the CSS is using Shadow DOM and Web Components. So they provide us a sandbox where we can be safe that our styles will not leak into the rest of the document, and whatever we are designing or styling for our component in there is actually safe against changes outside. There was a style scoped attempt, but that was discarded. There's other things or other candidates for scoping. The keywords you may want to use for searching for this is do not scoping or the add scope. And this is also currently in the CSS working draft spec. And then we also have some scoping through build tools, where we actually, where the build tools are like looking at our CSS and markup and then do some transformation in order to use existing technologies to provide us some scoping issue behavior. So there's a couple of techniques. One of them is to like definitely given scoping in CSS is just using a class. And so but then when we use a class, we can come into naming clashes. So as they are not sandbox, so one of the things to use here that build tools do is take the class and added some hash to it. So to make the class name unique in the whole document. And another technique is to use a data attribute and then combine the selectors under the hood to take your class name or your element selector and put it, like, connect it or combine it with the data data attribute selector to make it also unique amongst other styles or other selectors in your the styles. So for Ember, we have Ember CSS modules available, which is appending a hash to our class name and makes it unique. So which gives us a local class attribute, and with that we're using local and scoped styles. Whereas if we just use class, then we use global styles. So throughout the presentation, I most of the time already used local class, and so for this section, it's even more important as there's a difference between local class and class, and I will go over that, but just a heads up of what you can expect. So for the actual component CSS API that we are looking into is that we can or want to parameterize a component with values, modes, and parts. Let's start with values. We want to customize a default value with our own. So here we have the CSS of a button component, and it has a dark blue background color. Here's how we use that button component. We give it a local class and with a custom button because we want to have it in pink. And then we override the background color with pink. So I think that's what perhaps some of you are already doing to customize a given element. So the problems is that at first it is somewhat generally accepted that all CSS belongs to everybody, which like where you're changing the intent of the original author of a particular thing. So rules and their values can be internal to the components. And this is because some of these are processing the values through either a calc function or some color functions to come to other colors. So think about the button. We have a background color given, and then we may use a color function to calculate the border color in somewhat darker than the color that we pass in. So if we only change the background color, then this is lost. So what can we do against that is we provide a stable API for passing in values from the outside, and we use CSS custom properties for that. So our button example, just revert. So we change or we add a custom property, button background color. We set it to dark blue, and then we use the custom property as our background color. Same as here, nothing changed. But for the for our customization, we no longer change the background color attribute directly, or we use the button. We only change the CSS custom properties, so kind of like an input parameter to our component. So we are good, are we? So let's use the same class in the outer div to group some buttons and to change all of the buttons within that group to pink. So are we still pink? No, we are still in blue. Because the C and CSS stands for com break me, as this is what we just did. We break the cascade for in our example. So we must use a resilient and more stable interface. So let's do that. Here's the button example, but just in stable. We use a private kind of CSS custom property with an underscore, where we say, okay, by default, we take the button background color property as an input. So if you are passing this into us, then we use it. Anyway, we fall back to our dark blue. And then we use our background color CSS custom property for the rule. So this makes it stable, and we can use that in a cascading situation. Okay, modes. Modes are an opt-in to modify the rules or the values of it. So an example is this one. We stick with our button. We give it a button and then also a button class based on the intent that is an argument to our button component. So this is actually already a mode. So the button dash and then add intent is our modifier. And there's two explanations to that. So the first one is coming directly from BEM, where M or the modifier and is described as a flag on a block or element. Use them to change appearance or behavior. And then the second explanation is coming from Cube, where the modifier is kind of like the exception and is defined as an exception is a deviation from the rules outlined in a block. So for the modalities that we have as an opt-in, we can differentiate between them as defined modalities and undefined modalities. So for the defined modalities, here we have our pseudo classes like hover active for sort of quasi modes. We have area attributes. They are defined because they are backed up by a specification, what properties are available and what kind of values can go into it. For the undefined modalities, we have data attributes and also the class attribute. Now, let's go and look into them a bit more deeper for the undefined modalities, because this was a recent discussion on Design System Slack where people asked, hey, what is the difference, what we can use them for? And there were some interesting results or some interesting arguments. So I want to pass them forward to you. For the data one, that's where people refer to them as the dynamic description of of a component, where actually you make behavior and appearance as an information as you put them in your markup. So kind of like your own DSL that you back this up with. And then for the class attribute, use them only for static description, like the shape or the rough structure of the component that you are using or building. So here's using exactly this idea. We use local class to define our static behavior, and then we use data dash button dash intent to as a modifier for our dynamic behavior. And by using a certain or specific HTML attribute, we kind of like put this into information as it's no longer just a class attribute. So you have other advantages to query that, for example, in testing. And if we look at the CSS to it, we have also a private background variable here, our CSS custom property. And whenever we are testing or making the data dash button dash intent attribute selected checking for alternative, then we change the background custom property or value to dark green. All right. So this actually works for components as well as for utilities. And one great utility is the flow utility by Andy Bell. The flow utility lays out the children of a component along the block axis within them. And it does so by applying the rhythm through space or through a gap between those elements, which is using the old selector here in the middle. And then there is a modifier to that, the data flow end, where it says use this modifier to say all of the children from this one onwards go to the bottom of it. So I made an example here that's actually using exactly the code I showed you before. So on the left, you see the outer box is the container using the flow utility. And then inside you see the 4 boxes that are laid out with the same space between them. And on the right, it's the same markup as on the left, but just on the third box, I added the data flow and modifier, which is pushing this element plus all the other following elements to the bottom. So on the right, basically, you see this very often in navigation bars, for example, on Twitter, on the left. So we can use now these utilities inside of our components. So in this case, for the card builder, we're saying we're using the local class the card, and with the class attribute, so global here, we mix in the flow utility into our component. But this is, just a highlight here, and maybe you can spot a little bit of a problem, not really a problem, but the block element or the element specification is now split between HTML and CSS. So think about this. If you are now need to make a change to that component, you first need to look up which classes this component implements, and then you need to follow your code base to find those classes. But you have 2 spots where you need to look that up, like for the HTML and then for the main class, in this case, the card. So which yields a question of where are you defining your styles? What is your CSS architecture telling you? What are the guides to do that? So with like standard HTML, or like native platform support, we are used to what I showed you before, or with the help of some preprocessors, we can have one single place to actually define our styles for that card builder. So here I reduced the definition of the styles to only one class, which is card, and then here I'm using post CSS, also the preprocessor that like injects or loads all the mixins or functions, utilities into the card component. So now I'm down to only checking for one class, and in that class, I can see all the things that this component is made up of. So it's down to one single place where I can look up everything around that class, around that styles. And in this case, maybe command click in your IDE is helping you to get to the definition of flow if you forget what that is and need to look it up. So now when we use our card builder with the example code from above, we use our card builder, we yield the kit, we use a header, the image, a body, and a footer. And for the footer, we apply the data flow and modifier and saying, okay, here we push it to the bottom. All right, so maybe another example, a loading spinner. Maybe you are used to do something like that. You have a button, and then you have the add loading argument or similar. And then whenever this is some sort of a Boolean true, then we show a loading spinner to it. But what if we do use something else for it? What if we do not use the add loading argument? And this is really, really, really nice example I found, which is this one button. And then we have the area -busy attribute. And when that is true, we will show the loading spinner. Well, that's not my idea. That's actually an example taken from Pico CSS. So Pico CSS is a small CSS library that gives you some styling, and it does one very, very fantastic job. It's not using classes, or not that many. The main idea for Pico CSS is that it's using HTML as is and provides styling. So if you use proper HTML, you will be rewarded with styling. And it looks quite nice when you just look at the documentation for it, but then I try it and use it, and like I've never seen a more educational thing to use proper HTML and markup than this one. It was so great to use that and get this reward through style and design, which is really a cool thing to use. So you want to try that for yourself and take ideas from that as well. So very good job by Lucas Laroche, who is the author of Pico CSS. All right, so I talked a little while for modes, and I just want to give a summary to wrap this all up. Modes are an opt-in to change behavior and appearance. We have different modalities that we can use for that: static versus dynamic, informative versus descriptive. We can use an opt-in API, and this works with components and utilities and the combination of that. So what I didn't foresee when I was looking into this, that this actually has a huge impact on your CSS architecture in the way you want to write styles or styling and where to define them. So it's a great question you can answer through your CSS architecture as well. Last thing are parts. So where we define access to our internal elements, or also known as named blocks, and how to style them, which I think is a great successor movie to Harry Potter's Fantastic Beasts and Where to Find Them. So here's the initial problem where we use the header class, body class, and footer class as arguments, and we use HTML and JavaScript to actually solve a CSS and styling issue that we actually do not need to. So for parts, we also have some modalities available. So first one are just generic pseudo elements that we have, like before and after. There's also element-specific pseudo elements, like backdrop for the new dialog element. Then there are some that come by vendor prefixes, like --mouse progress bar, and for WebKit is --WebKit progress value, so they're not even aligned. And there's a couple of others as well. Then we have the role attribute. We have the item prop attribute, which comes with a schema. So this is kind of spec'd up, or has a spec as a backup. And then lastly, we have part as an attribute, which also was coming with the colon part selector in CSS and Shadow DOM and web components. So this is a thing or a mechanic to actually style something within Shadow DOM. Like Shadow DOM by definition is sandbox, and there's no way in unless we make a way through part. And then using the part selector is actually kind of like finding a gateway into Shadow DOM. It's like, okay, here I can make a change to that, as this is a public API that the component outer have given to us. So how we use that is, here's a modal component, and we use the dialog element, and then on the header, the body, and the footer part, we actually using the part attribute, and we give it a name. Based on the spec, you can give it a space-separated list of names. You're not only down to one. So feel free to make use of that if you want to, but for the selector part, I think it's better to stay with one. And for multiple values, it goes better with a colon part selector for accessing into web components Shadow DOM. So how we use them? Here we invoke the modal component. We apply our class, the delete blog post modal. We make use of named blocks, header, body, and footer. And now when we look into the CSS for it, we can actually style them accordingly. So we use our class names and then use the attribute selector to actually select the part and then the name to it. And we have a stable API to make customizations to that particular element within a component. And we do not need to go through HTML and CSS, HTML and JavaScript, or we can have this as a solution only in CSS. So let's discuss this styling chapter. Solving styling issues purely in CSS is actually quite challenging. So figuring this all out was not easy, but it's not that much to do, and it's actually very fun to do it. Like, I've tried all of them and used them, and it's quite happy to work with that. You can actually make APIs in CSS, not only in JavaScript and the like. Values, modes, and parts are a great thing to add to your CSS API or your component CSS API. And then also, like, do not forget to document strategies on how you want to define styling within your CSS architecture. But the big question is, how do we actually document this? How can we say, okay, this is our component and this is the valuable CSS API? Well, there is a good example from Shoelace. It's a CSS library, and also it comes with the web components. And here they do, what they do is on the documentation page, here in this case for the progress ring component, they outline the CSS custom properties, what the names, what the description are, and what the possible default value is, as well as the parts that are available to use for styling. So if we add this to our component specification template, then they actually are part of the signature of a component, and where we would define such a thing just in CSS land. But I think the tooling around this does not exist yet at all, or I am not aware of this. All right. So putting this all into practice, where shall you start now? And you may be thinking about your own digital product or your application that you have right now. You may have some sort of UI library design system already, which is kind of like the lowest level. Then there's the product level on top of it. However, this is structured in your architecture. How do you start here? How do you shape your components? How can you apply a little bit of the knowledge already in your system right now? But I want to draw your attention back to Bob and Greta here as well, one more time. As these are not digital products in the classical sense, let's think about cars and how they would be made up into components. Like, what if I give you out the challenge of turning them into components? Like here for the Bob, we have a mini component with a class Bob onto it to customize it. And on the right, we have a bully component and a class Greta to it to customize it. How would you approach it? How would you fill the 3 dots for the arguments, for the block params, and for the contents inside? Let's think about this a bit and recap a little of what we covered today. So each one for yourself a bit about what you can recap, what you can pull back in your mind about a couple of things. So you at first might remember some of the haptics that are coming. What are the individual parts that we can think of it, and how they are, what's the syntax to it, how are their mechanics, how can you use them? The design patterns, you can think about how each of those components internally is working, what they are made of, what are their engines, what kind of component types these ingredients are made up of, what are their purposes, what's the map of this component landscape. Instead of a design system, we would have the assembly parts, maybe wheels, rims, steering wheels, armatures, seats, and I'm already going a little bit from small to bigger, chassis as well. And what are the styling APIs? How can we make Bob green and Greta orange from the outside? All of the things are now coming together, right? So it's just not a digital product, but we can apply it in a space of creating car components. So if we use our component spec template again, or have a look one more time at it, it has become a little bit crowded. And so the question is, what can we do with that? So if we use component spec template, it's great to actually describe a component through that. For things like the patterns and the haptics, you can just do check marks and say, yeah, my component is implementing this pattern or this haptics. You can select the type. The signature is what you can express through the upcoming signature type as it's currently in RC. For the CSS parts, we need to find out a solution, and the classification is according to your own map. But where do you want to start with that? And I think, first of all, let it slowly grow into your muscle memory. Let it become your bread and butter. So you will not start tomorrow and remember all of that, but you might remember one thing. So that's good. Then use it. Maybe you can identify some of the patterns I described here and see tomorrow in your code. It's like, oh, look, this is what Gossi was speaking about yesterday. I just can recognize it. That's great. And from there on, you grow your repertoire. And basically, like for me, is applying the component spec is a thing within minutes. So this is just long learning that goes into it. And the more you can recognize of it, the more you also are able to see these things and kind of get an X-ray view into your components. As this is relevant for writing your own code, writing your own components, making component APIs, as well as when you read others' code. What was the intention of the author? What are my changes I want to do there? Will I like conflict an existing pattern in there by making my change? So this is some relevant questions you might have, and that's good. So the question is, can you use that as a documentation? Yeah, you can. And I tried this as well. And I figured out this is what it can or may look like. So you put a JS doc block above your component, and then just 4 bullet points to describe haptics, patterns, type, and classification. And then you write just one word behind that. It's a good exercise to do that. How you handle this in your team? Well, you need to figure this out. If I would be a coach in some athletic team, and then would I recommend this to my team? Well, I would answer this way. If your team is more consisting of triathletes, then yeah, you can go for it. If your team is more consisting of soccer players, then maybe it's not the best idea to use that. But for an exercise, of course. So if this is something that's helping you for designing your components or your upcoming feature to that, why not? If it's helping for a long-term strategy, cool. I definitely want to learn if this is something that's helping you as a part of a documentation and how you do that. But for me, I think classification as a starter is a really good thing. Draw a map of the components or the landscape of your system and draw areas to visualize the boundaries. Do that for yourself, ask that a teammate to do that, and then discuss the results. I think you will find something interesting. And definitely you can derive some guides from those areas. As this will have the most impact or can have the most impact on your team, as it eliminates avoidable discussion amongst peers, like how do we do that? Where do we put that? I've seen this boundary, I've seen this boundary, and we're not like quite clear. So if you have them some guides for it, this will help you align saying, okay, look, we have written this down here so we can refer to it. And that's like, okay, thank you very much. We can go and implement this right away. And the second thing is that it eliminates recurring decision findings, as those is always also already provided through those guides. So when you are about to design some components that you want to implement, then you can refer to that and see, okay, what kind of component do I need? What are the rules for it? It's like, okay, here's the one I need, and I know what to do instead of figuring this out over and over and over every time again. So just some real world example where you're asked, hey, please implement feature X, and the other team has already worked on something very similar, so you can reuse the snowflake they've already built. And like for me, it's like when I hear reuse, then a little bit of my alarm bells start, because there's this reusability fatigue, in which it's a trap. So somebody recommends some reuse to you, and it's like, yeah, you go for it, and then you end up in a trap. So why is that? Now, you might hear this. Oh, I only added 2 more arguments to their component so I can use theirs. That's a quote from the developer implementing that feature. And then when this is announced, like, okay, yeah, I did this maybe in stand-up or so, and then they'll say, yeah, he reused the component, or they reused the component, let's say, and then they cheer for you, and then the devs are more like, oh, they reused the component. So why are the 2 reactions so different? Because of the the dev is seeing something, and so what are they seeing? And the answer is the LMAO, which is a reference to Miguel Kanda. LMAO, what does it stand for? It's the large monolith with an army of options. So you make the one component bigger and bigger, and each argument adds more to the complexity. It makes it less changeable. That means the maintenance to make a change to that component goes up. So if you're growing your component with arguments, that's like contributing to the tech debt of your code base. That's always a sign to that. So watch out when you're doing that. And later you hear maybe this quote: I left you 99 problems, but they ain't mine. The same dev leaving the company. Okay, like jokes aside, let's solve this for real. How would we approach that problem? So how would we approach usability of another team? Like, first of all, it's great that somebody hinted at us, like saying, okay, another person of the team has already made the effort to create something that we need to use, and reach out for them to see what they have, what we can use, what we can do with that. That's already a good hint, and we can just be thankful for that. So we go and inspect the existing component that the other team or other team member already made. So if that component is a recipe, then all good, we can use it. So we wouldn't contribute more arguments to what maybe becomes a tech debt, because that's kind of like the idea of a recipe to be reusable and serve as a template to other components. However, if this is a snowflake, like a one-off component, and we are making changes to that, then the best idea is to extract that snowflake into a recipe component at first. Let the existing snowflake component that's already there that the other team made use that now created recipe component. It might be builder component, it might be base component, something like that. And then we use this new recipe component. So we are stable against their possible future changes. So if they change something on their snowflake component and we are relying on them, and now their changes affecting ours as well, this is perhaps not what we want. And so this way, by saying, okay, we're going a step back, making a base component, we can be more resilient against future changes and have a more stable API. So, all right, so which way you want to go when you are about to implement some components. Maybe there's always this naive forward lazy approach, just the way forward, and like having blinds on to not see what's left and right. And I hope I made you some looks left and right available, so you see some more directions in which you can implement some components. Maybe not only left these two, but more also on the side, a bit orthogonal to the way, the path you're already walking. And also tell us about your journey. How do you approach that? What was the first thing that helped you? What were the challenges when you were trying to use one of the things I'm telling you here? I think not only I am interested in hearing this, but also others as well. So please share. And with that, one more time, going back to this slide. As I told you in the beginning, this is like the slide to watch out for. I think all of these boxes are now filled with immediate content for you. There's also like more content swimming in the deeper waters where you made reference, but perhaps not need to be aware of its immediate usage. That's okay. Maybe you have a little Gossi on your shoulder, and the next time you're changing one of the things in your components or making a new one, making a new design for your component of that feature, this little Gossi will something whisper into your ear and saying, hey, look at the patterns, look at the type, or something else. And then you can go back here and see what maybe is good for your solution. What is a good solution for your challenge at hand? So if this is the thing, then I would be very happy. And with that, I have just some references left I consulted for this talk. And there's more references I had. And then I had even more references. And then the last thing is saying thank you for listening and participating and consuming my contents. Thank you very much.